Chapter 7 Entanglement writes reality, the new language of physics. It begins with a single question. What if reality is written in the grammar of entanglement? Not just particles zipping through space or waves rippling through fields, but patterns of connection in visible lines, linking one point in the universe to another, instantaneously and mysteriously. This isn't poetic speculation, it's the heart of quantum mechanics. And in the theory of RUEQFT, these lines, these entanglements don't just describe reality, they create it. Let's rewind. In classical physics, we're used to things having properties. Mass, position, momentum. We measure them, we predict them, it's neat and intuitive. But in the quantum world, things become relational. An electron doesn't just have a spin, it has a spin with respect to something else. When two particles are entangled, their properties are so deeply interwoven that measuring one instantly affects the other, no matter how far apart they are. Einstein famously called this spooky action at a distance. In most interpretations, entanglement is just a side effect of quantum weirdness. But in RUEQFT, it becomes central. Here's the radical idea: mass, damping, energy flow, even time itself may be consequences of entanglement structure. To see this, we have to look at a concept called Entangled-Entropy. This is a measure of how much one region of space knows about another. If two parts of a system are strongly entangled, the entropy is high, they share a deep connection. If they're isolated, the entropy is low, they live alone. RUEQFT says that this entropy is not just an accounting trick. It's a real physical field. It flows. It has direction. It can even cause effects like resistance, damping, and the appearance of mass. In other words, when entanglement collapses, when two regions lose their connection, it costs energy. That energy? It is mass. This flips everything on its head. In Newton's world, mass causes gravity. In Einstein's world, energy bends spacetime. But in RUEQFT, mass may be a side effect of how information flows between entangled parts of a field. The more tightly something is entangled with its surroundings, the harder it is to separate and the more energy it requires. That energy, by E equals mc square, is its mass. Let's take this further. When a particle moves through space, it doesn't just move like a billiard ball. It disturbs its surrounding field, breaks and reforms entanglements, like a swimmer pushing through water. That disturbance creates drag, a kind of quantum resistance. RUEQFT formalizes this idea through what's called pseudo-Goldstone damping. The rate at which the particle's motion fades is related to how entanglement entropy shifts. A beautiful marriage of thermodynamics and quantum mechanics. Even time behaves differently. Normally, we think of time as ticking at a fixed rate. But RUEQFT introduces a new factor, an information Lorentz factor, which slows down systems that are strongly entangled over large distances. It's a kind of thermodynamic time dilation. The deeper the entanglement, the longer it takes to equilibrate. In other words, the universe ticks slower where entanglement is stronger. So what does this mean for the nature of reality? It means we may have to abandon the idea that particles are the building blocks of everything. Instead, relationships, specifically quantum entanglements, may be the true atoms of existence. Reality isn't made of things. It's made of how things are related. This also touches on deep philosophical questions. Einstein believed in a universe governed by realism and locality, that things exist independently and interact only through local forces. Quantum entanglement, and RUEQFT in particular, challenges both. It suggests that the most fundamental features of physics, mass, time, energy, emerge from non-local structures. There is no absolute here or now in this framework. Only webs of entanglement shaping what we observe. And yet, it's not chaos. It's not mysticism. RUEQFT is a mathematically rigorous, renormalizable quantum field theory. It obeys the constraints of special relativity. It extends smoothly into curved spacetime, suggesting compatibility with general relativity. It doesn't break the uncertainty principle, it explains why it exists. Because in a universe where entanglement defines what is knowable, uncertainty is a natural consequence, not a bug. Let's pause for breath. You, the reader, might be wondering, why does this matter? Because we are on the edge of a new physics. A physics that doesn't just describe forces, but explains why they exist. A physics where the cosmos is not a collection of particles bumping into each other, but a grand, dynamic web of information shifting, flowing, collapsing, and creating the illusion of solidity we call matter. In this picture, you are not just made of atoms. You are made of entanglement. And every breath you take, every thought you think, every heartbeat, is part of the cosmic pattern. The invisible dance of information that RUEQFT seeks to decode. The universe is not silent. It is speaking a language. And that language is entanglement. Chapter 8: The universe reimagined a future in the language of entropy. What if the laws of physics we've held dear for centuries are not the final chapter, but only a prologue? What if the real story, the deeper engine behind matter, motion, and even gravity, lies not in particles or waves, but in how information itself moves through space and time? This is the future that the Renormalizable Unified Entanglement Entropy Quantum Field Theory RUEQFT dares us to imagine. Let's begin with a provocative idea: heat and information are not separate. They are two sides of the same coin. One governs thermometers and steam engines. The other runs your brain, your computer, and perhaps the entire universe. In classical physics, we learned that heat is energy in motion. Molecules jostling, bouncing, spreading. In the information age, we learned that every bit, every 0 or 1, has physical meaning. Erasing a bit creates heat. Processing information costs energy. And now, with RUEQFT, we discover that the flow of information might be as fundamental as space and time themselves. This isn't science fiction. It's quantum thermodynamics, the strange, but rigorously grounded branch of science that tells us entropy isn't just about disorder. It's about what we know, and what we can't know. And RUEQFT brings it all together by showing that entropy flows can shape the fabric of field theory itself. But what does that look like in practice? Imagine a new kind of device. Not powered by electrons flowing through silicon, but by carefully tuned entanglement patterns. A quantum engine where the working fuel is not gasoline or electricity, but controlled entropy gradients. In this future, computers might no longer suffer from overheating, because heat itself becomes part of the computation. Cooling systems might evolve into informational refrigerators, guiding entropy away through entangled channels rather than metal coils. Or imagine medical technologies that don't just detect the heat of inflammation, but sense the entropic coherence of a living system, allowing diagnoses based not on temperature, but on the flow of internal informational order. This isn't just better data. It's a whole new diagnostic dimension. Even our vision of space travel might change. Current rockets use chemical propellants, and tomorrow's may use ion thrusters, or even nuclear fusion. But in the deep future? A spacecraft that rides gradients of information, surfing the entropic contours of curved spacetime, could be a reality, drawn straight from RUEQFT. All of this rests on a shift not in what we observe, but in how we think about observation itself. RUEQFT tells us that everything we call a thing is really just a bundle of entanglements, localized, collapsing, and reforming. If that sounds abstract, consider this: you are not the sum of your cells. You are the network of how your cells relate. A single cell from your body cannot capture your identity, but the way they communicate, the entanglement of function and feedback, is what makes you you. So what does this theory say about the ultimate nature of reality? That perhaps there is no such thing as a fundamental particle. That instead, the bedrock of the universe may be a dynamic web of information, constantly shifting and evolving, and that what we call mass, time, force, and even consciousness may be emergent properties of this web's behavior. It's humbling and exhilarating, because it means we're no longer just observers of the universe. We are part of its processing. Every thought, every memory, every breath, is not just a chemical event. It is a node in a grand informational fabric. The stars burn, the galaxies swirl, and somewhere inside it all, we are entangled with everything. Of course, many questions remain. RUEQFT is not yet a complete theory of everything. It does not yet unite quantum gravity with a single equation, but it lays the foundation. It gives us a new way to ask the questions, and perhaps, one day, a way to answer them. What makes it special is this: unlike many abstract theories that live only in equations, RUEQFT makes testable predictions. It tells us to look for tiny but measurable, anomalies in how particles decay near critical points. It suggests new ways to measure entropy, and how damping rates can reveal the invisible tug of informational currents. In the coming years, experiments in quantum simulators, high-energy collisions, and condensed matter systems may shine light on these predictions. And if even one of them confirms the theory's forecasts, we may be witnessing the birth of the next physics revolution. The future of physics may not be about discovering new particles, but about decoding the invisible grammar of information that weaves everything.